The first part of question A asks us to write the chemical equation for the dissolving of solid MgF2 in water. So MgF2 will dissolve into two separate molecules, Mg2 plus and F minus. And since there are two F minuses on the left, there have to be two F minuses on the right. So that's why I added a 2 in front of the F minus on the product side. In the second part of question A asks us to calculate the number of moles of MgF2 that dissolved. And in the description, it gives us the molarity of F minus and the volume that the MgF2 dissolved in. So we just have to multiply molarity by liters to get the moles of F minus. So I did that over here, and then to get moles of MgF2, you have to divide that number by 2, because for every 2 moles of F minus, there was 1 mole of MgF2. And if you multiply all of those together, you end up getting 1.2 times 10 to the negative 4th moles of MgF2. In the third part of question A asks us to determine the value of the solubility product constant, KSP. And to do this, we need to multiply the concentrations of the Mg2 plus and the F minus. So first off, we have to find the concentration of Mg2 plus. And since we calculated moles, we can simply divide by the liters, which was 0.1, to get 1.2 times 10 to the negative 4 molarity. And to get KSP, you simply just have to plug the numbers in. So for Mg2 plus, the number was 1.2 times 10 to the negative 3rd. And for the F minus, it was 2.4 times 10 to the negative 3rd. But we have to square it because it had 2 in its coefficient. And we end up getting 6.91 times 10 to the negative 9th. And there are no units for KSP. Question B asks us to find which salt will precipitate first, CaF2 or BaF2. And I said the CaF2 will precipitate first because it has a smaller KSP value. Since the CaF2 and BaF2 have the same amount of molecules it dissolves into, you can simply just compare the KSP values instead of doing a calculation. And the second part asks us to calculate the minimum concentration of F necessary to initiate the precipitation of the salt selected in part B. And to do this, we have to use the KSP that they give us in the description, which is 3.5 times 10 to the negative 11th. And those numbers were comprised of the Ca2 plus and the F minus squared. And in the description actually gives us the concentration of the Ca2 plus, which was 0.1 molarity. So what I did here is I divided 0.1 molarity by 3.5 times 10 to the negative 11th to get 3.5 times 10 to the negative 10th. And that number is equal to F minus squared. So I simply just square rooted that number to get 1.87 times 10 to the negative 5th molarity. And the third part asks us to calculate the minimum volume of 0.20 molarity NaF that must be added to the beaker to initiate precipitation of the selected salt. And to do this, we can use the equation M1V1 is equal to M2V2. And in the description, it gives us the initial concentration, which is 0.2 molarity, but it does not give us the initial volume. And on the right side, we use the number we calculated in part B, and then the 500 milliliters that it gives us in the problem. And if you just do the math, you end up getting a volume of 4.68 times 10 to the negative 5th liters. And question C asks us to describe one procedure to redissolve the precipitate formed in part B. And you can just simply add more H2O to the solution. And if you do that, the molarities will decrease, therefore allowing more CaF2 to dissolve.